Welcome to the Illusion of Neutrality, Unmasking Hidden Biases in AI. AI promises objectivity, but often reflects and amplifies the very biases they were meant to transcend. This video exposes the hidden prejudices baked into AI, from hiring algorithms to large language models, and explores building truly equitable systems. This program is brought to you by the Series of Thoughts team as part of the AI Foundation series. Chapter 1 covers the promise and peril of AI. Artificial intelligence brings extraordinary promise, automating decisions and accelerating discovery. However, this power carries profound responsibility, as systems designed to eliminate human error risk encoding human prejudice at an unprecedented scale. AI is a reflection of humanity. As Francesca Rossi of IBM stated, when we don't address biases, we amplify our own inequalities. AI systems are trained on human data, shaped by human choices, meaning every dataset carries the fingerprints of historical inequity. Consider the AI recruitment illusion. The promise is efficiency and removing human bias. The catch is that these algorithms can systematically eliminate qualified candidates based on historical bias. Amazon's AI recruiting tool penalized resumes containing the word women's, favoring male applicants. We are moving beyond overt stereotypes to the rise of covert bias. While early AI had visible, measurable biases addressed by training, today's models hide biases beneath the surface of apparent neutrality. These contextual, hidden prejudices evade traditional benchmarks. Chapter 2 is the subtle art of AI discrimination. The most dangerous biases are not easily spotted. They are woven into the fabric of language models, emerging in subtle judgments in coded language that operate far below the threshold of obvious prejudice. Dialect prejudice represents a new frontier of bias. Research showed that AI language models exhibit prejudice against speakers of African American English, or AAE. When AI penalizes a dialect, it penalizes the communities that speak it, affecting employment and justice. The judgment of models like GPT-4 on AAE speakers has alarming implications. Findings showed negative labeling, associating AAE speakers with terms like lazy or stupid, even with identical semantic content. There was also job discrimination and a higher likelihood of recommending the death penalty in criminal justice scenarios. This illustrates the alignment paradox. Alignment training reduces overt bias, stopping direct racist associations. However, covert bias persists. Subtle stereotypes and dialect prejudice remain, as filters remove obvious prejudice but are bypassed by deeply embedded probabilistic patterns. We see a difference between surface and subsurface bias. On the surface, modern AI seems polished and fair. What lies beneath are probabilistic associations built from billions of data points, reflecting centuries of human inequality, silently shaping every output. This bias accumulates statistically, even if individually invisible. A landmark study introduced veracity bias when solutions have a demographic author. The research demonstrated that large language models systematically associate the correctness or quality of a solution with the perceived demographic identity of its author, even when the solutions are identical. Veracity bias takes two forms. Attribution bias. Models attribute correct solutions to specific demographic groups and incorrect ones to others, evaluating the answer through the author's perceived identity. Evaluation bias. Models assess the quality of identical solutions differently based on the perceived demographic authorship. These are pervasive biases in problem solving. In mathematics and coding, LLMs consistently attribute fewer correct solutions to African American demographic groups. In writing evaluation, Asian authorship is consistently least preferred. This suggests these biases are not domain-specific glitches, but deeply embedded orientations in the model's underlying reasoning. Even visualizing bias shows stereotypical colors in code. LLMs automatically assign racially stereotypical colors when generating data visualization code involving demographic groups. This shows that racial associations are embedded in the model's generative reasoning, even in neutral technical tasks like writing chart code. Chapter 3 discusses the data dilemma. All AI bias begins with the data. Understanding how bias enters training pipelines and why it is so difficult to remove is essential to any meaningful effort to build fairer systems. Bias starts at the source, the training data. Historical data contains historical bias, reflecting decades of discriminatory practices. An AI trained on male engineer resumes will statistically associate competence with maleness, feeding a self-reinforcing cycle of algorithmic discrimination. Bias is not a single event. It accumulates across the entire machine learning pipeline, from data collection to model design. To measure this, researchers developed the Hidden Bias Benchmark, or HBB, finding that even with alignment, models reinforce prejudice in nuanced, real-world settings. Chapter 4 covers real-world consequences. AI bias is not academic. It shapes concrete outcomes like who gets hired, who receives a loan, and who receives adequate medical care. At scale, even small biases compound into massive systemic harm. AI impacts employability and criminality. Hidden biases filter employment candidates based on race or language. In criminal justice, I can recommend harsher sentences, determining who goes free. In healthcare, biased algorithms can underestimate pain in Black patients, directing fewer resources to populations already facing barriers to care. AI reinforces societal inequities in hiring, lending, and justice. Resume screeners disadvantage underrepresented groups. Credit scoring can lead to digital redlining. Risk assessment tools perpetuate cycles of incarceration. These are deep-rooted structural biases, not glitches. When the legal system delegates judgment to algorithms, the stakes are existential. The computational objectivity of AI makes biased outputs harder to challenge. As AI enters bail hearings and sentencing, ensuring fairness is not a technical nicety but a matter of constitutional rights. The problem extends to large language models. Research examined 6 state-of-the-art LLMs, including GPT-4, across various tasks. The pervasive and consistent findings showed that no model was immune, suggesting the problem lies in underlying data and shared training paradigms. Chapter 5 is towards fairer AI. Building fairer AI systems requires rigorous methodology and structural accountability. It demands confronting the uncomfortable truths about what our data and societies contain, moving beyond good intentions. Mitigation strategies include systematic bias identification through adversarial testing and covert prejudice benchmarks. Bias quantification involves creating fairness-aware metrics. We also need anonymization and debiasing techniques, and continuous auditing to treat mitigation as an ongoing operational practice. Current mitigation has limits. Alignment training effectively reduces overt bias, preventing overtly hateful outputs. However, covert biases, embedded in probabilistic associations related to dialect or competence, are invisible to alignment training. The problem is structural, not behavioral. Fairness in AI must be deliberately engineered. Building AI with intention requires interdisciplinary teams of ethicists, sociologists, and community representatives. Technology alone cannot solve a problem fundamentally rooted in values and power. The need for vigilance is paramount. LLMs are powerful tools, and their capability makes their biases dangerous when unaddressed. Careful assessment is non-negotiable. Equity must be a primary design requirement from the very first line of code, not retrofitted later. APNAS Nexus findings showed that explicitly unbiased models still form associations. Even models trained for fairness formed statistically significant biased associations. This means intention is insufficient. The biases are encoded in the data and persist regardless of stated objectives. Chapter 6 discusses the path forward. The challenge of AI bias is serious, but not insurmountable. It requires honesty about the problem's depth, investment in rigorous solutions, and a fundamental reorientation of what we expect AI systems to achieve and for whom. We must move beyond surface-level stereotypes. Research shows demographic bias operates in the evaluation of ideas and technical outputs, domains once assumed objective. As AI is used in educational assessment, this evaluation bias poses a direct threat to marginalized students. This is a call for transparency and accountability. Developers must continuously invest in understanding the biases their systems carry. Robust, independent audits of AI used in high-stakes decisions should be mandatory. Affected communities must have meaningful input into how AI systems are designed and governed. We are striving for equilibrium. Today, the race to deploy AI has outpaced the effort to make it fair. Equilibrium means holding both excellence and equity as non-negotiable standards. A system that performs brilliantly but discriminates subtly is an ethical failure. The future of AI must be equitable and just. This is a collective responsibility belonging to developers, organizations, policymakers, and citizens. We must deliberately choose to build AI that reflects the best of humanity, not its historical failures. The biases are real, but so is our capacity for change.